morning, children. So today we are going to discuss the important model in definite integration for the competitive exams. That is on modulus. We are observing a question here, that is minus 1 to 3 mod of 2x minus 3 dx. How to solve this question in mathematical way and how to solve by using graphical way we are going to discuss. Here we are discussing solution in mathematical way. When we are discussing solution in mathematical way, here we are observing a mod function that is 2x minus 3. So it is having a critical point. That critical point we are getting when that is equated to 0. It will be x value 3 by 2. So 3 by 2 when it is a critical point, if I take 3 by 2 on the real line, we will be observing two regions. One is more than 3 by 2, other is less than 3 by 2. So when x is greater than or equal to 3 by 2, whatever value of x you take, it will be positive. Inside mode whatever we are observing will be positive. When it is positive, modulus is not required. So it is defined as 2x minus 3. When x is less than 3 by 2, then clearly this inside thing will be negative for whatever value of x you take. So that's why the modulus, if we want to remove for that, we have to remove with multiplying with negative. So that's why it will come out to be minus of 2x minus 3. So here after defining in both the regions, here minus 1 to 3 we are integrating. So directly we cannot integrate without removing the modulus. So in different regions we need to integrate it. That is, one is from minus 1 to 3 by 2, the other is from 3 by 2 to 3. Yes. Now we know the critical point is 3 by 2. So we are splitting the region minus 1 to 3 into two parts. One is from minus 1 to 3 by 2, and the other region we are having from 3 by 2 to 3. So mod of 2x minus 3 we are integrating with respect to x. Here mod of 2x minus 3, here we are integrating with respect to x. Now between minus 1 to 3 by 2, this 2x minus 3 will be negative. So that's why we will write it as minus 1 to 3 by 2 minus of 2x minus 3 dx plus, and 3 by 2 to 3 it will be positive. So 3 by 2 to 3 I can straight away write it as 2x minus 3 dx. Mod is not required. Now integrating this, the integration of this will be minus of integration of 2x plus 3. It's a linear function, so I can write it as 2x minus 3 whole square divided by 2 into 2, since x is having 2 as a multiple. That is integrated from minus 1 to 3 by 2 and plus, and the integration of 2x minus 3 will be 2x minus 3 whole square. It's a linear. The power will be increased in integration divided by 2. Again the multiple of x is 2, so that's why we are multiplying in the denominator. So that is 3 by 2 to 3 we are having. Now coming to this, when we are going for substitution of upper limit and substitution of lower limit, we will be getting the value of this. If I put x value 3 by 2 here, this will be 0. So that's why minus of substitution of upper limit, it will be 0, and substitution of lower limit, when I substitute minus 1, it will be minus 2 minus 3 whole square, that is 5 square or minus 5 square, 25 divided by 4. So minus of 25 by 4 plus, and substitution of upper limit, here it is substitution 3 when I substitute here, 3 2s are 6, 6 minus 3 will be 3, 3 square will be 9 divided by 4, and the substitution of lower limit, it will be 0. So that's why you are getting the answer 25 by 4 plus 9 by 4, it will be 34 by 4. So answer is 17 by 2 square units. Actually, when I put mod to this function, it is nothing but the area bounded by that mod function. Yes, here we are doing the question graphical way. First of all, when we are trying in graphical way, for every mod function, we have to check the critical point first. Critical point is a point where modulus is 0, so that's why 3 by 2 is a critical point. So 3 by 2 to 3 for upper limit, we are having one region, and less than 3 by 2 means minus 1 to 3 by 2, we are having the other region. 3 by 2 to 3, this inside part means 2x minus 3 is positive. So modulus is not required. So it is defined as 2x minus 3. It is defined as 2x minus 3. So if you want to draw the graph of 2x minus 3, will be extending. But we are having mod. So where it is negative, if I put mod, it becomes positive. So that's why here it is defined as minus of 2x minus 3. Here it is defined as minus of 2x minus 3. So that is what we have done in mathematical way. So we are integrating this 2x minus 3 between 3 by 2 to 3. And we are also integrating minus of 2x minus 3 between minus 1 to 3. Adding them we are getting. But the height which you will get for 2x minus 3 at x equal to 3, you substitute x value 3 here, so that 6 minus 3 will be 3, height is 3, and the base which we are getting is 3 minus of this 3 by 2 will be 3 by 2. So we know the area of right angle triangle is half into base into height. So half into 3 by 2 into 3, so it is 9 by 4. And even the height at x equal to minus 1 we are getting is mod of minus 5 will be 5. So that's why height will be 5. And the base which we are getting here, it is 3 by 2 minus of minus 1, that is 5 by 2. So again area of this right angle triangle portion will be half into base into height. It will be 5 by 2 into 5 into half, means 25 by 4. 25 by 4. Now this is 25 by 4 and this is 9 by 4. We need the area bounded by this curve between the limits minus 1 to 3, means this portion plus this portion. So that's why the final answer we are getting is 25 by 4 plus 9 by 4 will be 34 by 4. It is 17 by 2 square units. What we got in mathematical way, we are also getting same in graphical way, but graphical way is optimal solution always. We will not lose our time in solving the question.